Well, welcome to Tube Time, episode 5! Welcome to Tube Time on Cool Dude Clem's Electronic Workshop. Anyway, the votes have passed and you asked for it, or the votes have passed and you asked for it, so going to make a power amplifier using one vacuum tube. And oh god, my camera's glitching out again. I'm charging the battery for my other camera, so when that's done, we'll switch over to that. Today we are going to make a power amplifier using this one tube, and obviously a couple of resistors and capacitors as well. Now you might remember in one of my previous videos I made an amplifier using a separate triode and pentode. Well, this thing has the triode and pentode built into the same package. We have the triode over this bit here, which is this little bit here, and the pentode bit right there on the other side. So a pentode on the left, triode on the right. Just seeing if you can make out the actual little individual windings there of the screen. I mean, of the control grid, but of course it's not. I don't think it's going to focus at this length. So let's take a look at the parts we're going to use. Obviously there's the valve. We're going to need something to connect this to a speaker, so output transformer. Going to need to be able to adjust the gain, so potentiometer, and of course various capacitors and resistors. I think my webcam is actually designed to behave on hearing that it's going to be replaced with another camera. So anyway, this is my design that I'm going to go with. And the tube I'm using is a 6 something 5 something. No idea what those characters are because I don't speak a single letter of Russian. So that means I couldn't look up the tube to find out the pin layouts or anything like that. But thing is, the person who sent me the tube, and thanks once again, also included a datasheet of an ECL85, which I think is the same tube. So anyway, gonna build up this whole circuit here, test it, and probably have to tinker with it to get it to work properly. So anyway, gonna go and build this now, and I'll be back with it built, and we'll see how it works. We'll see how well it works. Okay, I've made it. Looks like a huge mess of wires at the moment. And it sort of works and it sort of doesn't. But mind you, I didn't expect it to work perfectly first time. And I'll give you a demonstration of how it sounds. I've got it hooked up to this speaker right here. And we're going to play something from the reel-to-reel. Well, I'm going to play something from the reel-to-reel. And play. Well, it is a valve amplifier. Yeah, I recorded some stuff from Team Fortress 2. Okay. It's freaking loud. Volume control works. Alright, let's stop that. Don't know if I'll get into any copyrights for that. It's hard to tell what you can play and what you cannot play on YouTube just lately. As you probably could hear, it's fairly distorted. But I think I know the problem. I'm also using my Jello Vision camera because I just charged the battery for that, so I can... So that's why the picture's not all going like this and stuff. Now, can you see the meter? I don't know. Something about cameras. They have an inability to see an LCD screen. See if that any better? Yeah, it's sort of better, you can see it. So anyway, I decided to probe the supply voltage, which comes in here. And look what we have. We only have about 83 volts supply. This is the main filter capacitor. Let's see what voltage we got there. We only got 115 volts there. Then after the choke, there we've got this capacitor here. It's gone down to about 79 volts now. It's crazy. The filament supply still seems to be quite happy though. Well, actually, that's gone down a little bit as well. I was getting about 6.1 volts there. I'm only getting about 5.5 volts filament now. I'm surprised that this thing is actually working at the voltage it's getting. Because if you remember, that's being powered off the isolated AC. And we're already getting 94 volts. What is going on? I'll tell you what's going on. These transformers cannot handle it. I'm gonna have to make a better power supply. I'm surprised that this thing is even functioning on a voltage that low. I did hear it whine a little bit while it was starting up, and it's never done that before. I mean, this thing is probably working overtime trying to get the voltage to what it should be. Right, well, I've upgraded the power supply. I've put in that ancient transformer that's specifically suited to power up valve circuits, and now getting a lot more power. I've also replaced the choke with this much bigger one. Yes, I'm still using a transformer as a choke, but we get much more output voltage. We're now getting about 308 volts across that capacitor. I don't know if you can see that. Again, camera's weakness for seeing meters. And across the final output capacitor, getting about 261 volts, so much more voltage. However, still got a few bugs to work out. Now, I've got some of Cave's messages from Portal 2 on here.
Welcome to the Enrichment Center.
Well, Cave, you sound terrible.
Making test participation mandatory for all employees, the quality of our test subjects has risen dramatically.
Yeah.
Employee retention, however, has not.
Yeah, it's still sounding pretty fuzzy. Okay, I'm just going to move this transformer because that's getting a bit... There we go. Not going to touch it because that transformer does get pretty hot. Not quite as hot as this thing gets though. Doesn't red plate though, which is a good sign. Or at least I don't see any signs of any red plating going on, so I think we're okay in that department. Of course, the camera cannot see anything at all now. Turn the lights out. Don't worry, the filament actually looks quite bright in real life, but on the camera it's very dim. I don't know why. The first rule of finding out what's wrong with electronics: thou shalt test voltages. So this is our supply voltage coming in right here. About almost 260 volts. That's absolutely fine. Right, let's see what voltage is going to the screen grid. 169 volts. That doesn't seem to be too bad. Right, so let's see what voltage is on the plate of the triode part. 45 volts. Alright, let's see what we got on the plate of the pentode. I'm trying to do this, putting myself in a weird position so my hands don't get in the way. Making sure I put my thing across the right wire here. Alright, so we got 139 volts. That would explain why this little transformer's getting pretty dull. Why that transformer gets pretty warm. So everything seems to be okay. Right, well, let's test our bias voltages. And I can simply do this by measuring across the cathode resistor. So this is the cathode resistor of the pentode. Let's see what we got. Well, that's a little bit higher than I expected. We've got 28 volts there, so that resistor's going to get pretty toasty. Good thing I put a 35 volt rated capacitor there. Alright, so we got about 28 volts of bias on the pentodes grid. Let's check the triode. Let's see what we got there. And, oh, less than a volt. Well, that might explain it. Should have about at least 2 or 3 volts there. Well, less than a volt. Should be higher than that. Okay, so that could be the problem right there. Could be a problem with the bias in the triode section. Okay. Alright, what I'm going to do now is I'm going to inject a signal directly into the pentodes grid and see how that sounds. Okay, so this is the line out from the reel to reel. I'm just going to put this directly onto the middle pin of this variable resistor, which goes to the control grid of the pentode section. So strangely enough, I'm not hearing anything. It's weird. Should hear something. Just reduce the amount of resistance there. Okay, that's rather odd. I'm not hearing anything whatsoever. Or maybe it's not so odd, considering that I'd actually plugged this into the line in instead of the line out. So let's try again, and already my camera's batteries are running out. I only charged this yesterday, and I haven't filmed that much with it.
Make life rue the day and thought it could give Cave Johnson lemons. Do you know who I am? I'm the man who's gonna burn your house down with the lemons. I'm gonna get my engineers to invent a combustible lemon that burns your house down.
Okay, well, it definitely sounds distorted there, so I think we know where the distortion is coming from now. It's in the pentode section. My guess would it would have been in the triode section, considering that the bias is a little bit off. But no, it's in the bigger section of the tube, so I've got to find out what's causing that, and maybe we can bust this thing. Well, I was thinking that maybe we've got a bit too much current going through this thing, so I've added another resistor and capacitor in line with the one that's connected to the cathode of the pentode side, so we've got about 940 ohms worth of resistance between the cathode and the ground. So I have now 40 volts at the cathode of the pentode section, and on the transformer got about 206 volts. So that transformer should run a little bit cooler now, because it's not got so much voltage across it. And all that aside, playing the tape, it's still
Cannon of the human race. Here I go. And I am
distorted.
Continue testing. Pure Intellect Cave here. Not to brag, but while you were cat-assing that last test, I rewrote the collected works of everything ever. If I gotta read this garbage for eternity, I might as well improve it.
Yep, I talk garbage as well. Anyway, I'm not licked yet. I thought the first thing I would try is a different output transformer, and what do you know? Sounds about 100 times better. No more distortion. And for some reason the battery on my camera is just going up and down at random. Okay, so this is the transformer that I was using before, which is still hot from its previous run. Now this transformer, this one, has a primary of about 1,000 ohms. Okay? However, I tried it with one of these doorbell or boombox or whatever you want to call it transformers, and this one has only about 400 ohms primary, yet it works about 10 times better. I think this tube likes to be put under stress. This is the final design. As you can see, I've got everything all nice and soldered up now, because before it was going slightly in the background. Possibly because of tons and tons of loose connections. So anyway, we've got about 960 ohms worth of resistance there for the cathode resistor of the pentode part of the tube, using a 470 microfarad capacitor for the pentode section's cathode resistor. I know it's getting a bit confusing here. I had to stop and think about that myself, actually. I've also increased the cathode resistor for the triode part. I've increased that to 4.7 ohms. 4.7 kiloohms. So it should have a bit more bias. One of my peeps, one of my subscribers, suggested I should make a speaker out of one of these enclosures I have. So I have gone and done that. Put a speaker in, even added a bass reflex port. We'll see how well that works. Oh, and for those of you who want a closer look up at the power supply and the modifications I've done to it, well, here it is. You might notice that this transformer is still in there. Now, all that's doing is the relay and nothing else. Because this transformer's primary is connected to the mains the way it normally would be. Well, it's connected up to the switch, but... So we have the output from this transformer instead of this transformer. And everything else is pretty much the same. It's on and powered up, and I can still hear some static coming from the speaker. Even though I've soldered everything in. It's kind of unexpected. Don't know if you can hear that. You know, it's hard to find something that I won't get, where I won't be had for copyright. Got this really old record on the turntable here. God only knows how old it is. It looks like a 78, but it's actually a vinyl 33. So, let's see how this turns out. Playing the second song in. Oh wait, that one's a bit depressing. Let's go to the third one. Yeah, that's better. Okay, now let's go to the amplifier.
Make it soon. If your heart can hear me, darling, won't you make it soon? Every star above me knows we shouldn't waste that moon.
Well, I think that sounds pretty good.
If you really love me, darling, won't you make it soon?
Let's try to adjust the bass reflex port.
Will you come to me to stay? I'll worry watching every lonely day slipping away. Come and hold me close, and then I'll never know that loneliness again. Never again. So please, I need you near
Right about
me,
there.
darling. Won't you make it soon?
And of course you couldn't see what I was doing. I was doing this. See if it sounded better with the bass reflex covered up or not.
When will you be near me, darling? Won't you make it soon? If your heart can hear me, darling, won't you make it soon? Every star above me knows we shouldn't waste that moon.
Well, okay, I think... Alright, let's just stop this now.
Love me, darling, won't you make it?
There we go. Well, I'm going to say, apart from the unexplained static noise that I really have no idea where that's coming from, it's a pretty successful experiment. Let's turn this off. Now this is kind of weird. So when I turn this off, it makes a bit of a weird noise. There we go. Don't know what it is that causes that little squeak there, but whatever. Well, okay, so here is my final design. As you can see, it's almost identical to what you saw before, except of course there's those two resistors I changed. I mean, this one here, which is now 4.7k, and this one here, which is 960 ohms, which I made out of two 470 ohm resistors. And well, there is my single tube amplifier using a triode pentode combo. So anyway, we're just gonna let the thing speak for itself. Anyway, that's just about it for this video, so just gonna wrap a few things up. Still got a little bit of that strange static. I have absolutely no idea what's causing that. I also decided to put a 1k resistor between the potentiometer and the grid of the pentode. Even though this circuit is my own design, I saw that in a few other circuits that used this, so I decided to do that myself to see if, well, just to see if it would make any difference, but it doesn't seem to. Anyway, the other strange thing is that the grid on the pentode side should be at 0 volts, but when I measure it, as you can probably see, we've got about 44 volts, and that's should be at 0, or very close to 0. So anyway, I'm just going to take some final voltage measurements so you can see, for those of you who are curious, so we can see what's actually going on. So the supply voltage of my improved power supply is about 255 volts, more or less. On the suppressor grid, again, this is in the pentode section, we've got about 200 volts. 200 volts. The plate voltage seems to be a little bit high. We've got about 10 to 20 volts less than what the supply voltage is. So I may reduce the cathode resistor and so I can get more current flowing through the tube. So I get more current in the output transformer. But for the most part it's working, so I might as well leave that as it is. Anyway, moving on to the cathode side, the triode side. Well, the plate voltage is about 63 volts, so that's pretty good. Anything between 50 and 150 is, as they say, in the ballpark. We got about 1.3 volts at the cathode. Still not quite as high as I'd want it to be, but increasing that resistor to 4.7 kiloohms has definitely improved it. It works, so I'm not complaining. And the grid is right on 0 volts, right where it should be. Or almost 0 volts, maybe. Just a couple of millivolts. Anyway, that's it for this video. And yes, you've been listening to me talking through this amplifier. Well, recording for me talking through this amplifier. But anyway, that's it for this video. And like I always say, until next time, goodbye.